So let's take a look at these. That's fun, right? Yeah. Let's see your kind of reaction again. All right. I got a sarcastic laugh. I don't blame you on that.
Do you know who the sarcastic is?
Well, at least one of them. So on this very first problem, fractions are sort of evil, as people think. Even my calculus students, sometimes I have somebody who has trouble with fractions, right? So this problem's got a little bit of everything in it. It's got a mixed number, it's got division by fractions, it's got subtraction, so for that you're going to need...
Common number.
Exactly, cool. So real quick, you know you can't, when you add two things, like I can add x and x, what do I get?
2x.
That's crazy. But can you add x and x squared?
No.
No, it's not x cubed, right? Because addition, subtraction requires what?
Like terms.
Like terms. Can I multiply x and x squared?
Yes.
Hell yeah, what would you get there?
X
Good, because I got one of them times two more of them multiplying, so I got 3. So multiplication division is not so restrictive. It doesn't need like terms. In this case, it needs like bases, but it doesn't need like terms. Are you guys with me? So when you add, subtract fractions, you must have like terms. And really what that means is if I had, of course, 8/9 minus 1/9, I could do that.
Yeah.
Because I have 8 of these minus 1 of the same things. That's just like 8x minus 1x. With me?
Yeah.
So LCD is required at the same time you need like terms, because it really is the same thing. Okay, cool. A lot of you guys are like, yes, no. But it's a really nice way to look at it. It's not even a way to look at it, it's just that's why it is the way it is. So what's the very first thing I should do on this problem?
Common denominator.
I like it. So you can get a common denominator. Common denominator. And of course that would be 10. I like it. So the LCD, even better than CD. Lowest common denominator. You wouldn't be wrong if you made about 20, but you're just doing extra work. So it could be 3 and 2/10 minus 1/10. I like it. There's one little thing I would have done differently, but it's just a question of when you're going to do it.
I applied the multiplied the
fractions
3
first.
times the 2 to make it all fraction versus...
So it'd be 10 times 3
Yeah.
is 30 plus 2. So you could have done it here. 5 times 3 is 15 plus 1 is 16. And then 16 over 5 would have become 32 over 10. It's crazy how it all comes back. So very often it's just a question of when do you want to do something. Right? It's not really a different way of doing it. And of course inside there I get what? 31 over 10. And when I want to divide fractions, what do I do?
You switch them with this one?
Yeah, multiply by the reciprocal. I like it. And do you guys know why we do that?
Yeah.
Alright, cool.
No, why?
If I had 8 divided by 1/2. The quickest way to do that actually is, if I have it written like this, that kind of looks disgusting, but it's too bad. 8 divided by 1/2, I can write that as 8 over 1/2, right?
60.
Now, if I can make the bottom 1, then the answer is staring me in the face from the top. Are you with me? If I make the bottom 1, the top is the answer. Right? Something divided by 1 is itself. So how do you make the bottom 1? Multiply by 2. So that becomes 1. So 8 divided by 1/2 is 8 times the reciprocal. So you can imagine, if I put anything down there, 7/4 divided by 3/5. Well, that would be 7. Can you guys see that? That would be 7/4 divided by 3/5. Right? We love fractions inside of fractions. How do I make the bottom 1? I multiply by 5/3. That is why division of fractions is equal to multiplication by the reciprocal. Cool, how you guys doing? Any guys ever seen that? I mean, that's why that is. I mean, never, hopefully you're picking up now that I'm one of those people that hates if you say, yeah, if you say so, I'll do it that way. But, so you should say instead, I don't see why the hell that works that way. I should be able to explain to you why something works. That's my job. So you should be able to ask me anytime something doesn't make sense, why we do something. That's what I love about this job, is figuring out how to explain why we do it that way. I have to be able to. If I can't, I should go home. So take that as a challenge if you want me to get fired. Oh, no, the second one. Oh, we're not done with the first one. Last thing to do here is,
2. Cancel out.
yeah, the 31s go away. 10 goes into 20 twice. So the answer for the first one is 2. I like it. It's not 42, sorry. You can try to argue with me, but it doesn't work here. This problem, of course, and this is I got to be careful because what you use here, you use everywhere. But this is the kind of problem that specifically is what kind of problem? Order operations. I like it. So what's the saying? PEMDAS, please excuse my dumbass son. Or dear Aunt Sally. Right? A lot of you guys are the dumbass son, but so. But some of you guys might have sons, I don't know. One of them might be dumbass. It's a very good chance. Because men are that way. So, very first thing I want to do is PEMDAS. And I hate that it's very often written like this because it's stupid. Right? You're all like, well, that's how you spell PEMDAS. Well, because it could have been PEDMASA. Because it doesn't, whichever one of these comes first is what you do first. It isn't multiplication before division. It isn't addition before subtraction, right? If it was addition before subtraction and you got $8 and you owe me 12, but then you find a 20 on the street, should you have money at the end after you pay me off? Should you have money left over? Yes, okay. But if you do 8 minus 12 and 20 is 32. 8 minus 32, you owe, who do you owe $24 to? You with me? So do not take PEMDAS so straight line literally. It actually should be written like parentheses first, then exponents, then either one of these as it comes, then either one of these as it comes. Right? That's the true order operations. And the reason we do that, that's like math grammar, right? It's the same reason you wouldn't say, blue, me, go. You know, there's a certain order to put the words in, so I know what you're talking about. There's a certain order that you do the operations in, so we agree on what the answer is, right? It's math grammar. That's why it sucks when you first learn it. But we should all be pretty good at this. What's the very first thing I'll do then? Good, inside the parentheses. So I get 5 minus twice. So everything else can stay the same. Two of the biggest mistakes I see is somebody writes a 3 in the front. What did they do wrong? So right here, somebody would write 3 on the next line. 3. Because 5 minus 2 is 3, man. But this is not 5 minus 2. This is 5 minus twice this divided. I don't know what the hell this thing is. So I don't know what to subtract from 5 yet, right? So you can't subtract something that's a part of another problem, right? I'm going to do multiplication before I do subtraction. The second biggest thing is somebody writes here 12. And I know that happens like a lot. And you might be like, why? What's wrong with that? Let me show you. Running out of room back here. So real quick, just look at a little tiny problem. If I had 5 minus 4 divided by 2 times, let's just focus on this piece. 4 divided by 2 times 3. If I had this. How can you rewrite that? How can you rewrite the division bar? You can use the division bar. So 4 divided by 2 is 4 over 2. And then you take that and you multiply by 3. So you have to divide by 2 before you can multiply by 3. You have to do it as it comes. Not multiplication first. This is what I meant earlier by it's not MD necessarily. It could be DM. It's whichever one comes first. Because if you do 4 divided by 6, that's not fair. 4 was only being divided by 2. Why is he being divided by 6 now? That's not fair. Okay, how we doing? All right, maybe. So here we get, the next thing I could do here is exponents, good. So I get 5 minus 2 times negative 8, good. Good. Negative 2 times negative 8, positive 16. Good. Division here. This whole thing comes next. The addition is last here, right? So 16 divided by 4 is 4. 4 times 3 is 12. 17. Sweet. Now, of course, I showed more steps than you might have to yourself. But you do have to show me some steps. The less you show me, the less partial credit I can give, because I don't know what happened. It's that simple. I need to see your reasoning. Part C. This is one reason why when I teach this, I still talk about it, because everybody knows it. But actually, there's sort of an evil thing about teaching FOIL. Because, well, number one, it's not necessary. Oh, you guys, do you like FOIL first, outer, inner, last? It kind of collects your thoughts and everything. But you don't need to do it. It's really unnecessary, because if I had this, if I had one thing sitting out here, if I just had a 2x out here, what would I do with it? Distribute, right?
Yeah.
Distribute. So here I've got two things sitting out here. So I distribute this first, and then I distribute this next. So FOIL is really just repeated distribution. You got more than one thing out here, so each thing gets a turn. This dude gets a turn across. This dude gets a turn across. Now look, first, outer, inner, last. That's what I ended up doing, but do I need to have... That's actually extra shit you got to memorize. And I only have so much space in my brain. I don't know about you. Right? So why would I memorize something new when it's just distribution? I already know distribution. And does FOIL help you out when you have this?
No.
What would that be? That would be like formula. You need some extra letters, don't you? Because you got the middle, first, middle, first. What? Right? No, not good. So, but it's so much easier if you think it's just this dude gets a turn and this dude gets a turn. Then I don't care how long I make this other dude. I don't care how long I make either one of them. It's the same stupid idea, right? Cool. So, this guy, what do I get? 2x times x squared. Good. 2x
Cubed.
Beautiful. Because you got an extra x coming in there. You had 2 already there. So you got 3 now. That's this guy. Minus, good. 4 x squared. I like it because now you got x squared.
6x.
Plus 6x. Minus x squared. I like it. Plus 2x. Minus 3. So you can do it this way. You can line up your like terms as you go or not. So you get 2x cubed.
Minus 3x.
Careful.
Minus 5.
Minus 5x squared. Good, because they're the same sign, so you add them. Plus 8x. Minus 3. Sweet. How are we doing? Some guys might realize, possibly, that means, if I said factor this, you could factor it like that. Now, this is not something we can factor yet. In fact, one of the first things we're going to talk about is factoring, but later this semester, we're going to learn something called synthetic division. Some of you guys know it. I see the heads, and some of you guys are like, who makes this shit up? But you'll see when we get there. It's a really powerful factoring tool. If you go into pre-calculus or calculus, you've got to know your synthetic division. All right, especially if you take me. How are we doing so far? Everybody good? How about part D? What does a negative power mean? Even better, that means flip. So if it's on the top and it's a negative power, it wants to go down. If it's on the bottom, it wants to go up. Be really careful, though. Does the 24 want to go down? No, 24 is not to a negative power, right? What's the only two things to a negative power? Yeah, the 6x's and the 7y's. So first off, easy part, how do you reduce 24 to 15? 8 over 5. And these 6x's want to come down. There's already how many down there? So how many are there now? 13. These 7 want to go up. There's already how many up there?
14.
There's 7 up there, so now there's 14. Done. Don't make a big deal out of that problem. Negative powers are not mean at all. They just mean I don't like where I am. So negative powers are division. Right? If I have x to the negative 2, it means 1 divided by x squared. It means like you have a debt of 2x's in a way. So something, if it's already on the bottom, it would flip up to the top. It would reciprocate up to the top. Okay, I like it. What about part E? Poor little dude. Oh, sweet. Part E. What's going on with a 0 power? I like it. It's a 1. And the easiest way to see that is, what's something divided by itself?
1.
1, right?
Gotcha.
Unless x was 0. That's the only one that makes everything freaky, is 0, right? But what's the rule when you divide? What do you do with powers? Subtract. 2 minus 2 is 0. So anything to the 0 power is 1, except 0. This guy is weird. It's actually called an indeterminate form that you'll talk more about if you ever get to calculus. Right? If you don't get there, it's too bad. You'll never talk. Besides what I just did right there. So here, 3 to the 0 power is
1.
That's crazy. 2 is just sitting there. What's this to the 0 power?
1.
So 1 plus 2?
3.
It's crazy. And this one we just talked about earlier, right? To add fractions, you have to have like denominators. That was very nice here. They already have like denominators, so I'm allowed to add them. So what do you get?
2x plus 2.
2x plus 2.
X plus 1. It's 2.
Now, can you just cancel these x's?
No.
Yay! Because addition can't be canceled by division. I like it. But you can do what on the top? Factor out a 2.
X
X plus 1. I like it.
Over x plus 1.
Over x plus 1. And of course now,
2.
this is 2 times this divided by the same thing, so they can cancel because they're opposite operations. You get a 2. So you can x. Yes, sir.
Why did we not just get 3x plus 2 minus x over x plus 1?
Oh, we did. So the first step really would have been 3x plus 2 minus x over x plus 1. But of course the next step now is like terms. So 3x minus x. And that gets us to this step where we factor. Yeah, so the first step is make the denominators the same. Then you're allowed to combine them, so that means get your like terms together. And then you see at the very end, can I reduce anything? Can I factor something, which will make something cancel possibly? How you guys doing so far? Is this coming back? Was it really far back in the brain?
Yeah, we're still working on that.
Oh, C? C was that thing. Is that cool? Okay. Let's see, so that was that. What about number 2? Did this one freak you out?
Yeah.
So what's the first step when you're solving an equation? You look for distribution, right? Yeah. So here you get
2x.
Negative 3x plus 12.
good. The biggest mistake I see is that. And what mistake did I make?
Negative 10.
No.
Yeah, negative times a negative should be a plus. And that is just such an evil little thing. You gotta be careful. And over there you get negative x
Negative x plus 2.
plus 2. I like it. Oops. How we doing? So, yes, I think somebody said great. I thought somebody said wait. So I was like, what's going on? Oh, sweet. It's even worse. I can't hear shit. So what do I do here? Yeah, 2x minus 3x is
Negative x.
negative x. Negative 2 plus 12,
Plus
10.
Negative x plus.
Now here's where you might freak out a little bit.
Yeah.
You gotta move the x's, so you try to get them together. So he's like plus x to make it cancel, and they go away. Don't force it to stay. It doesn't want to be there. Right? Let your x's go away if they want to, because you end up with 10 equals 2. Don't write a big paper say, I've discovered that 10 equals 2. If you owe me $2, you actually owe me 10. No. What does that mean?
No solution.
Good. Because and this might be something where you're like, okay, that is just, I know math is evil, but that is just so evil. But this is not math's fault. We started with a bogus equation. We just didn't know it. Math said, all right, dude, if you want to write that equation down, you're fine as long as 10 equals 2. And we go, oh yeah, 10 doesn't equal 2. So I wrote a bogus equation. Of course, I did it on purpose. I wrote a bogus equation. I didn't know it until I got here. This is math's only way of telling me, dude, your equation's bogus.
Yeah.
So in the real world, If I have a little company and my boss says, write out the equations that tell us what we have to do to make $18 billion next year, they're probably going to come back with, no solution, dude. You're a little company, I don't know what the hell you're thinking. So in the real world, there are equations that have no solution, and they're telling you, given what you got, there's no way to get what you want. That's what the equations, that's Matt's way of telling you, tone your expectations down a little bit. All right? How are we doing? If I would have gotten 10 equals 10, it would have meant what? All real numbers. Because if it's always true, then my equation is always true. So really, when I solve a normal equation that I get a nice answer for, subtract 1, x equals 2. When this is true, then this is true.
Yeah.
So here, when this is true, never, then this is true. Oh, I can't make it true, no answer. If I got 10 equals 10, when is that true? Always.
Yeah,
So therefore, the answer would be everything. Everything would work. How are we doing so far? Okay. Hopefully it sounds, yeah? I don't like that. All right, how about part B? What way do you guys solve that? I like it. So the one suggestion I have is to multiply everything by 12. What good would that do? Yeah. LCD is the number that has all the bottoms in it. So if I multiply by it, they will all cancel. Now, I'll over-cancel some of them, but who cares? If I have a way to kill fractions, I will. And I'm pretty good with fractions. I would hope that would be kind of inherently no. But if I can, I'll kill them. Why not? I mean, they're a very simple place to make a mistake, right? So there are other ways to do this without killing your fractions. And if you want to, that kicks so much ass. But actually, there's no need. If you multiply by the LCD, it cancels here. Right? What happens here? 3 goes into 12, 4. 4 times 2x is 8x. What am I doing? And then here, 6 goes into 12 twice. 2 times 5 is 10. And now that looks awesome. What do you do? Minus x. 8x minus x. 7x. Add 10. And then finally, divide by 7. X equals this beautiful thing there. So be careful. If you had a teacher in Math 90 who always made the answers come out to whole numbers or something, let go of that expectation. Right? In the real world, answers are not always whole numbers. They are very often weird things. They're negatives. And later this semester we'll talk about non-real numbers. Right? What's called imaginary or complex numbers. Okay. All right. So what way did you guys, there's several different ways to graph this. What's one way somebody did that? So one way is to find the intercepts. Is that what I was starting to hear? Set y equal to 0, find the x-intercept. Set x equal to 0, find the y. I like it. So let's try that. If I make x 0, y is
negative 4.
Negative 4. So if I make x 0, y is negative 4. If I make y 0, x is 6. Thank you. You guys with me? And all I need are 2 points, as long as I trust them really well. It's 2 points. If I get a third point, then it will tell me if something's wrong. Of course, my third point could be wrong, which would suck. But all I need really are 2 points, 0, negative 4, and 6, 0. 6, of course, is up there somewhere. Now, if you want to, you could make your scale different, right? So I don't know if anybody did 2, 4, 6 here. Then it would be there. That's cool. Or if you don't make your scale different, you just have to kind of place it off of there, and then there's my line. Somebody do it a different way.
X plus B.
I like it. So real quick, there's that way. If you did it that way, get those 2 points. If you do it this way, solve for y, because of course the equation of a line in general is, like you just said it, mx plus b. Right? Where m is the slope, and b is the y-intercept. I like it. And of course it makes sense because if x changes by 1, y will change by m times that. So that m, I often call it the amplifier, or, it doesn't always amplify, sometimes it diminishes, but still, it's the same idea. Whatever x changes by, y does m times that much. That's why it makes sense. It's the slope. So, if I solve this for y, now let's kind of cut to the chase. If I add 3y, subtract 12, divide by 3, I'll get 2/3 x minus 4. Now it's good so far, because earlier we got the y-intercept was -4, and thank God we still have it as -4. All right, 1, 2, 3, 4. And then this tells me to go, good, up 2 over 3. If I would have drawn a straight line, it would have been, so here's my 6 we got earlier, remember that?
Yeah.
I like it. You guys kind of with me? Because it goes, the most hated topics in algebra normally are word problems, number 1. Graphing is number 2, and then kind of like fractions and decimals and stuff is number 3 in there somewhere, normally. It might be a different list for you, but that's pretty much what I can count on. And then finally, this last one I want to do, since that's what we're going to talk about mostly today, and by the way, we are going to take a little break after this, right? We will take breaks. I'll need them just as much as you will. Right? We're not going to go straight till 12:15 we go to? No, we're not going to do that. But this should be one of the last things you talked about in 90. And again, if you're coming from somewhere else, hopefully you've done some factoring. The idea here is that any 3-term dude could have come from the multiplication of 2 2-term dudes, right? Because the middle term could have come from combining like terms. So how do I do this? What do I look for? X squared is x times x. So now all I need are 2 numbers that multiply to be 20, but they can't be anything. -20, I like it. They can't be like -4 and 5, because at the same time they have to make 8. Good. So since it's positive 8, I know it's 2 and 10 will make 8 if they're different signs, and the bigger one's got to be positive to make it positive 8. I like it. So that should be a relatively easy example of a trinomial factorization. And then I do part B to you. Now be careful. Did anybody do this?
No.
Good, because it's not an equation. How do you get answers? I hate it when I teach everybody what to do when it equals 0, and then you go make everything in the universe 0. It's like, that's a very bleak, everything is 0. It's like, damn, that doesn't seem good. So no, this is not a solution question. It's not an equation. You stop there. It's just a factorization. And real quick, I heard a little bit, I didn't know if, when I say simplify, that is actually the opposite of factor. Simplify means do the operation. So multiply, divide. So here I would multiply that stuff out. Factor means undo the multiplication. Get it back to its parts. So they are completely opposite instructions. So what do I do here? What form is that in?
Y squared minus 9 and y squared plus
I like it. Right? It's the difference of squares. Y4 is y squared. 81 is 9. And to make there be no middle term, they have to add to be 0, so minus plus. So difference of squares, I call it a thank God problem. Because all I got to do is cut everything in half and make it minus plus. Or thank whatever deity you pray to. Flying spaghetti monsters, whatever. What's that? Now am I done?
No.
Good. And that word completely should be a clue. Right? This is sort of like me saying factor 18 completely, and you say 2 times 9. You're not done, because 9 is 3 times 3. So here, which one of those can I do further? This guy I can do further.
y plus 3.
Beautiful. Y squared is y. 9 is 3, minus plus. This dude I cannot factor, because there's no way to make the middle term disappear and make the last term positive. Because the only way real numbers can add to be 0 is if they are different signs. But when we get to complex numbers, we'll actually be able to factor that. Oh shit. But we're not there yet. So right now, we leave that dude alone. And then everybody's favorite problem. right? The cubes. All right, so. Good. And the reason people hate this problem is because it's the form, or you have to memorize just the form of it. You can't work it out. Squares, I can break things in half. I can actually do something. Cubes, I have to remember how to kind of place things, right? But the nice thing is, with squares, what do? I cut everybody in half, put one thing there, put one thing there. Cubes, then I'm going to put one thing there and the other two things there. So on one level, at least, it's very similar to squares. I want to break it up. But if I put one thing in the little dude, I'm going to have to put two things in the big dude because it's cubes. There's three of everything. So what is there three of? Three W's and then three threes. So what I tell people is, when you see a cube, let me get some more room. So W, 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 and 3, 3, 3. When you see a cubes, you do little dude, big dude. The little dude is a little dude, so he only gets one. He puts one W and one 3. Good, same sign. So the other two W's have to go here. The other two 3's have to go there. Now the big question is, why do you need any other shit? Right? W times W squared is W cubed. 3 times 9 is 27. Why did you math people have to make it complicated? Because I also get minus 3W squared. That sucks. I don't want minus 3W squared. And I also get 9 freaking W. I don't want 9 freaking W. Right? I don't want any kind of 9 W. So I get these two extra pieces, right? I do get my W cubed, and I do get my 27, but I get these extra freaking pieces. So I call this last dude the cleanup guy, right? So it's always one of each, two of each, the product in the middle. And since he's a cleanup dude, he's a cancellation dude. You want him to cancel the shit you don't want. That's minus. This has to be plus. So look what you get. You get minus 9W. See that? Minus 3 times 3W is minus 9W. Right? And then W times 3W is 3 positive 3W squared. It kills the stuff you don't want. You guys semi with me?
Nope.
Shit. Like that.
How are you supposed to just know it?
Huh? No. So here's the thing. The thing about math is it's always looking for patterns. So what we look for is what's going to make this thing work. So one thing that makes sense about this, at least one thing, is if I have 3 of stuff in there, I have 3 X's and 3 2's, right? If I put one X there, then I have to put the other 2 there, so I get my X cubed. So far that makes sense, right? And if I put 1, 2 here, I have to put the other 2 2's here. So far that makes sense, right?
Okay.
So every time I do that, I'm going to get extra stuff.
Right.
Right? Stuff I don't want. So that's the middle guy, the thing that always works. The thing that will always work is you multiply the pieces together that's in the little dude. And you make it the opposite sign.
Okay. Now going back to the original C question with the negative 27, is that why you put the negative in the first one, the W minus 3?
I love it. Exactly. So we just saw that W cubed minus 27 factors to be this. If it would have been W cubed plus 27, the only difference would have been that's a plus
The other one's a negative.
and the other one's a minus.
Okay. I got it now.
I like it. So there's only one negative in the whole thing. So that's why people hate cubes, is because it's actually the one form that you just have to sort of memorize. But the more sense it makes, 1 of each, 2 of each. Why? Because you got freaking 3 of everything. So how much more sense can that make than that? And the only one that doesn't make the most sense in the world is that middle dude. But he's the one that always works. If you do that, it'll kill the stuff you don't want. Okay, so let's go ahead and take a break. We'll take come back at what? You see what that says.
It's 11:48.
Come back. No, it's 10:48. Come back at 11. Come back at 11.